Hello everyone. The topic that we'll be taking is internal RAM and register banks. So about the internal RAM, there are 128 bytes of internal RAM on 8051, and the locations go from 00H to 7FH. 7FH in decimal is 127. So from 0 to 127, a total of 128 locations are there, and these locations can be accessed directly as memory locations. The memory locations are now divided into three groups. The first group consists of register banks and stacks. The register banks are further divided into four banks. The next 16 bytes are for bit addressable read and write memory, and we'll be taking all of this later. And the remaining 80 bytes from 30H to 7FH, known as scratch pad, it is used for read and write storage. So this is what I said. The from 00 to 1F, these are four register banks, and from 00 to 07, and then 08 to 0F, 01, 2, 3, 4 banks, and then from 20 to 2F bit addressable RAM, and the remaining part is scratch pad RAM. So register banks, as I said, these are divided into four parts. Four register banks are there, and each one has 8 registers. The register bank 1, it uses the same RAM space as is used by the stack. So here's an example: move R0, hash 99H. This moves 99H into RAM location 0. So these are the register banks with their RAM addresses. For register bank 0, these are the addresses, and for register bank 1, these are the addresses, and similarly these are the addresses for register bank 2 and register bank 3. So by default, whenever we switch on the 8051, the register bank which is set is register bank 0. However, we can switch to other register banks by the use of a register called program status word. The third and fourth bit, that is here, this bit and this bit, these are used to switch to the other register banks, and this is how we do it. Register bank 0 is set when both the fourth and third bit, that is PSW.4 and PSW.3, both are 0, and for the other combination, that is for 0 1, for 1 0, and for 1 1, register bank 1 2 and 3, they can be set. Next comes the bit addressable locations. These are what you see here. These locations, these are the bytes from these are the 16 bytes starting from 20 to 2F, and these are the bits of these bytes. So let us say if I have to access the 0th bit of location 27, so that is here, and if I have to set it to 1, so what I'll be using is set B and 38H. So it will automatically set the 0th bit of 27th location to 1. Next is the stacks in 8051. Stacks are very important if we have to move from one part of program to another, and we have to store the variables somewhere, so that's where stack comes into use. And when we move back to the stack, we can use the whatever we have stored using the pop operation. The stack pointer in 8051 is only 8 bits wide. That means it can take values of 00 to FF only. So here's the push operation. So first of all, I've in this example I've moved 25H into R6 and 12H into R1. The command used is push 6, so that is the contents of R6, that is 25H. These are to be moved to the location pointed by stack pointer. So stack pointer is now pointing to 07. The push operation, it takes part in two steps. First of all, the stack pointer, which is now pointing, which is here pointing to 07, it is incremented by 1. So now it points to 08, and 25H In the second step 25H, it is moved to here. And the next command you can see is push 1, that is the contents of R1 to be pushed onto the stack. So once again this same thing happens, the stack pointer pointing at 08, it is incremented by 1, so it now points to here, and the data, that is 12H, it moves to this location. So that's how we push the data onto the stack. So now how we retrieve the data from stack, that is the pop operation. So I've used pop 3, that means whatever the stack pointer, whatever is the data stored in the location which is pointed by stack pointer, that has to be moved to register R3. So 54 here is moved to R3, and in the next step stack pointer, that is decremented by 1. Stack pointer here was 0B, pointing to at 0B, it is now decremented to 1, it now points to 0A. And in the command pop 5, the location, the data which is stored in the location pointed by stack pointer, that is F9, that moves to R5. And in the next step the stack pointer, that is again decremented by 1, and it now points to 09. So that's how we retrieve data from the stack. Now whenever the 8051 is powered on, the stack pointer, it points to 07 location, and the very first location where it can write is 08. So this causes a conflict between the register bank 1 and stack. The register bank 1, it also starts from 08, and so does the stack. So whenever, if you have to use if you're using stack, then we should avoid using register bank because it may cause an error. So, and the stack pointer, it increases, stack pointer is incremented, it is not decremented. The reason being, it points to location 07. If we decrement it, then it will point to 6, 5, 4 and so on to 0. And once we reach 0, we run out of space for the stack. So for this reason, the stack pointer, it is incremented, and it can go to 7F, which is not the case practically, but it can go to 7F. And in this way we have a huge space where we can store the values, that is where we can use the stack. So that's all, and thanks for watching.